Hey, Chemistry from High Point. This is actually just a review video that I'm going to make up for you so that you can recall how to do the different types of calculations before we end this chapter. So the first calculation that you learned was a mole-to-mole conversion out of a reaction. And so to go over that, I'm going to go over example problem 911 out of your book, where it says if 25 moles of diphosphorus pentoxide reacts with water to form phosphoric acid, how many moles of water are required? Here is the balance equation, so I'm going to write that. It says P2O5, 3H2O, gives us 2 phosphoric acid. I'm sorry, I knew that formula was wrong. There we go. All right, so we want to start with 25 moles of diphosphorus pentoxide. So that's right there. So it says 25 moles. All right, so that's our given. That's our given number, unit, and substance. We want to convert that to moles. So we're going from moles of P2O5 to moles, from goes on the bottom, right, to moles of phosphoric acid. All right, so we know that the units will cancel out, the substance will cancel out, and we're going to the units that we want. Now all we need to do is make sure we have the correct numbers. From the equation, how many moles of diphosphorus pentoxide are there? There's 1 because there's no coefficient in front of it. There's 2 phosphoric acid, so that goes with the phosphoric acid, 2-to-1 ratio. So then there are converting 50 moles of H3PO4. All right, so that one is pretty simple. I did something wrong there. All right, well that would be if it were asking for phosphoric acid. It's asking for water. So let's go back to that. All right, let's go to water instead. It's actually asking for water, so 3 moles of water. All right, because that's a different coefficient. So 1 mole of diphosphorus pentoxide is equivalent to 3 moles of water in this particular reaction. So the new equivalent is 75 moles of water. All right, so that's a mole-to-mole reaction using the equation. Let's go to a mass to mole, or mole to mass. All right, mass to mole, 912. Let's make that mass to mole. All right, so 912 says how many moles of phosphoric acid can be formed from 3,550 grams of diphosphorus pentoxide. So right away we're going to write down the number it gives us. 3,550 grams of P2O5. All right, so let's read the question again and make sure I get what we're asking. It says, how many moles can be formed of phosphoric acid? So first we have to get to where we can find moles of phosphoric acid. That's going to be our last step, but we have to get from grams to moles. All right, so to get from grams to moles, we have to have the grams cancel out. Grams has to be in the bottom, and it's equivalent to a mole. So what is the molar mass of P2O5? We need to use our periodic table, and our book's going to give it to us here anyway, so I'm just going to check that out. 141.9. 141.9 grams are equivalent to 1 mole of P2O5. It's asking for the moles. I'll just put it moles of H3PO4 is what it's asking. All right, and we can go, the next step, we can go from P2O5 in moles to H3PO4. All right, so this is the middle step of our mass to mass calculation, which you did several for homework. All right, but we're going to end there because it's not asking for the mass of phosphoric acid, it's only asking for the moles. So we need our periodic table to find the numbers for this. So, sorry, we do not need our periodic table. That would be bad. We need our coefficients. We need the reaction. We need 1 P2O5 and 2 H3PO4. All right. So before we finish solving this conversion, let's make sure we did it correctly. Grams cancel out, substance cancel out. Moles cancel out, substance cancels out. Do we put in the correct numbers? We use the periodic table to go from grams to moles. We use the reaction to go from moles of one substance to moles of another substance. So everything looks good. It's asking for moles of phosphoric acid, so we know that's where we want to end. So 50 is the answer. 50 moles H3PO4. All right. What if it gave you moles and it was asking for grams, right? If it did that, then you would not have this step, okay, in your mass to mass calculation. You would start with this step and you would end with a mass calculation, okay? So take a look at your mass to mass. Let's just review mass to mass. Okay, mass to mass gives you grams of its given, whatever's given, right? Then you go from grams to moles with the periodic table, moles to moles with the reaction, and then you go from moles to mass, grams of what it's asking. All right. From the periodic table, right? Remembering that these two are flipped so that the units cancel out. All right. So here you're going from mass to moles, so we're cutting out this step. The question, I believe one of your homework questions gives you moles and it's asking for grams. So you're going to cut out this step and go from moles to moles and then moles to grams. All right, let's talk about percent yield because that's new from your notes. On page 244, example 917, it says aluminum hydroxide is found in many antacid tablets because it reacts with hydrochloric acid from the stomach to form aluminum chloride and water. If 15 grams of aluminum hydroxide is found in a single tablet, determine theoretical yield of aluminum chloride that would form if you assume that there is an excess amount of hydrochloric acid. All right, a lot of wording in there. Let's just start with the number and then decipher what all that means. 15 grams right here, grams of aluminum hydroxide. All right, that's the amount you're given. The unit is grams. The substance you're given is aluminum hydroxide. What the question is saying is that you're starting with 15 grams of aluminum oxide or hydroxide. It's going to react with an excess of hydrochloric acid. So what it's saying is we don't care about that quantity. We don't care about the mass of the hydrochloric acid. We don't care about the moles of the hydrochloric acid. We only care about aluminum hydroxide, which is the number they gave us. So we're good there. So we need to find out the mass of aluminum chloride that would form. That's what it's asking. So we need to go through a whole mass to mass calculation. And I'm going to make some room here. So 15 grams of aluminum hydroxide. All right, first step, grams of aluminum hydroxide to moles of aluminum hydroxide, and it'll be 1 mole because that's what we're going to find the molar mass of, is 1 mole. All right, then it will be moles of aluminum hydroxide. I don't know why I keep putting that in parentheses. No, all right, aluminum hydroxide and moles of aluminum, I believe it's chloride. All right, and then we're going from moles to mass. Moles of aluminum chloride to grams of aluminum chloride, and that's what it's asking. All right, so information's already given since this is an example problem. So 78.00 is the molar mass. That's from the periodic table. Moles of aluminum hydroxide to moles of aluminum chloride is a 1-to-1 ratio. That's from the reaction. Moles back to grams from the periodic table, 133.3. Okay. All right. So just quickly, everything cancels out properly. All right, and you can check all that. And you're left with mass of aluminum chloride. The answer is 25.63. All right, and I'm going to come over and change the camera because I know you probably can't see that. There we go. All right, and so the problem says, what is the theoretical yield? Well, if all of the 15 grams of aluminum hydroxide was reacted, theoretically this is what we would get. But in any reaction, not all of the substance is going to react. There's going to reach a point in the reaction when there's not enough aluminum hydroxide, the strength isn't strong enough, and maybe there's just not, it's not connected, there's not enough to drive the reaction when you reach a certain point. So it's going to end. Maybe it'll end when there's 3 grams of aluminum hydroxide left. We don't know. But what we do know, because in letter B it says 25 grams of aluminum chloride were measured. So 23 grams, 0.00 grams of aluminum chloride were actually measured. So this is the actual yield. All right, so in order to find the percent yield, we're going to find out our theoretical, like if you got 100%, well, if the aluminum hydroxide got 100% on its test, on its reaction, and it all converted, then it would come out to 25.63. All right, but it didn't. Okay, it was able to get 23 grams. All right, so we are just going to take what the actual score, if you will, the actual results over the possible, okay, how much could it possibly get, the theoretical yield, and we're just going to divide those and make it into a percent, so we'll multiply by 100. So we'll get 0.8974. We'll get this ratio of 0.8974. All right. 0.8974 gives us a ratio times 100, and we got, it's an 89.74% yield. It's actually a really good reaction if you get 90%, and that is close to 90%. So that would be a great yield in the lab. All right, if you still have questions, please let me know. Hopefully this will definitely help you on your calculations for your homework.